Hey everybody, welcome back. In today's video, we're going to cover how to solve systems of equations using elimination. So I'm going to use the same example from last time so I can it'll just be a little easier for you guys to understand how both processes work, and I can save some time so I don't have to identify the variables and rewrite the equations. If you're watching this video and if you haven't watched the previous video and you don't know how I came up with the equations or the variables right here, then you can go ahead and watch the previous video where I use substitution to solve this equation, or the system of equation. So in this one, we're going to use elimination instead of substitution. So hopefully by the name, you can tell that we're going to eliminate one of the variables in the equation, and we'll end up solving for the other one. So how can we do this? Let's find out. So if you look at the coefficients of the variables, they're different, obviously, right? You have a 2 as opposed to a 1 by the x, and a 1 as opposed to 4.5 by the y. Now, if you remember your combined like terms methods, right? If you have 3x minus 3x, everything cancels out and you end up with 0, right? The 3 minus 3 cancels out, the x minus x cancels out, you're going to end up with 0. So that's what we're aiming for here. We want the coefficients to be the same so that we can either add or subtract the equations and eliminate a variable. So we're going to go ahead and eliminate the x just because it has 1 and 2, and those are just easy whole numbers to work with. But to do that, we have to multiply everything up here by 2, which means both the left-hand side and the right-hand side have to be multiplied by 2. Now this is key. This is the golden rule of algebra. Whatever you do to the left-hand side, you must do to the right-hand side. Otherwise, they're not the same equation. Now why is this? I'll show you guys a quick example right here. You'll have 8 equals 8, which is a true statement. But if you add 3 here, and you don't add 3 to the other side, you end up with 11 equals 8, which is a false statement. But if you add 3 to the other side, all of a sudden, you're going to get 11 equals 11, which is still a true statement. And that's why whatever you do to one side, you have to do to the other. So if we multiply the top equation by 2, we're going to get 2x plus 2y is equal to 6,000, and 2x plus 4.5y is equal to 6,200. Now we'll draw a line here because we're going to either add or subtract these variables. So what do we want to do? Well, we can just go ahead and draw a minus here because now you get 2 minus 2, which is equal to 0. So you're going to get 0 here because the x variable is going to cancel out. So now you're left with one variable, and we've covered how to solve equations with one variable. If you do 2 plus 4.5, you're going to get 6.5y. Sorry, 2 minus 4.5, my mistake there. So 2 minus 4.5 is going to get you a negative 2.5y. Let me erase the plus as well. So you're going to get negative 2.5y is equal to negative 200. So in other words, if you multiply everything by negative 1, 2.5y is going to be equal to 200. Now if you looked at the last video, this is essentially the same solution that we got. Solving for y, we get y is equal to 200 over 2.5. And you can plug that in your calculator. It should be about 80. So your y variable is 80, which gets you your x variable. Plugging it back into the original equation and not the altered system over here, we're going to get x plus 80 is equal to 3,000. Solving for x, we get x is equal to 2,920. So what does this mean in terms of the question? That means 80 adults, let me add on 80 adults. So 80 adults and 2,920 children attended the fair. In the next video, we're going to solve systems of equations, or well, solve isn't really the correct term, but we're going to walk through systems of equations which either have no solution or infinite solutions. You'll run into these once in a while in algebra.